welcome to Ed Plus, to our guest speaker, our fellow students and colleagues. We wish everyone safe wherever they are. This is the first issue of Ed Plus Talk for this session 2021 and 2022. You are with me, Dr. Atta. I will be your moderator for the talk this morning. So for your information, Ed Plus is our architecture and design talk series inspired by our own Department of Architecture. We have started in this session in early 2020, but before that, we have actively organized a series of talks and lectures at our studio. So at one point, we thought it would be a good idea if we could open the session to the public, since the pandemic has actually allowed us to do so. So the topics of choice traditionally would be related to the current projects our students are working on. So this time it is of designing a pedestrian bridge. So we thought the best person to talk about these are the good people behind the famous Darul Hana bridge in Kuching, or you refer to it as the Harmony Bridge. So we are honored today for having Mr. Kamal Fozdar and eventually Ms. Architect Chun Chien. Thank you also to Mr. Mervin for arranging this for us. Both of our speakers will be talking about the designing and the construction process of the bridge, something our students could learn directly. A bit of introduction. Kamal Fozdar is the principal of Fozdar Civil and Structural Engineering based in Perth, Australia. He has graduated with a Bachelor of Science with honours in Engineering Science, major in Civil from University of Warwick, United Kingdom in 1982, and Master of Science in Structural Engineering from University of Manchester in 1987. So projects that he have done, including Sarawak Parliament House, or locally known as the State Assembly Building, and the Harmony Bridge, both are completed in 2009 and 2017 respectively. Other projects include Bahá'í Lotus Temple in Delhi in 1986, Mount Carmel Bahá'í projects in Israel, completed in 2000, Cadogan Song School in Perth, 2017, Westin Hotel, Perth, 2017, and Aloft Hotel and Offices in Perth, also in 2017. And our second speaker, Architect Chun Chien, is currently the principal for CC Architect. Their completed project includes Vivacity and Galacity. So I believe I have taken much of your time. Let's just dive right into the main agenda of today. So before that, a bit of housekeeping rules. Kindly turn off your microphone if you are not speaking. You are encouraged to switch on your cameras. If you must ask questions, we would allow that at the very end of this session. Alternatively, kindly leave your questions in the chat box. We shall attend to your questions during the Q&A session later, which will start at 11:45. So with that, I would like to hand this over to Mr. Kamal. Thank you very much.
Thank you very much for the introduction. And when the architect and when he joins us, Mervin, if you could just let him in and make sure he also joins the discussion straight away. Yeah, I discussed with him yesterday about the what we were going to talk about, and I said, this is a very unique project to a certain extent, and it's all about finding harmony in society and between the north and south side of the river. And the thing I mentioned to Chun Chien was it's also about finding harmony between the different disciplines in a construction project, which is why we were very happy that both the architect and the engineer would be speaking together. Hopefully the architect will be arriving soon. And so I was going to run through the history of the project, how we formed the concept design, the technical background, the skills that enabled us to create this design, the design development process, the launch of the project, and the construction and the official opening. One thing that you didn't mention just now with the introduction is that actually I'm a local boy. I'm from Kuching, and this is very much a Kuching project. It was designed by a Kuching team, so very much local produce, you can say. And so I went to school at Lodge School and St. Joseph's School. So this is the result of the education that I received in Kuching institutions. And the same with Chun Chien. It's exactly the same situation. So that's just a little bit of an introduction to the talk. Now I'll just go straight on. This is, I just wanted to go through the history of the pedestrian bridge in Kuching, because even before I got involved in the project, Chun Chien pointed out to me that there was an initial proposal for a pedestrian bridge near the Riverside Majestic Hotel. This was in about the year 2000 as part of a Kuching urban master plan study. And just on the, I don't know if you can see my mouse here, this is the design that was proposed at the time. And it was between Riverside Majestic and to the, I think the east of Fort Margarita there. So this was the first pedestrian bridge that I'm aware of that was designed for central Kuching. This is the first one that we proposed, actually. This is a pedestrian bridge, an S-shaped, a Z-shaped one, I should say. It's a reverse S. So it's a Z-shaped one that we proposed between Fort Margarita and James Brook Cafe. This was proposed in 2003 at the time that the Dewan Undangan project started. And it's a similar size to what we have now. But the location was very, very different. And the design was a little bit different also. But this is the first one that maybe got the attention of the state leaders, you can say. And they were very interested in this bridge because lots of them, they work on one side of the river, but they live on the other side of the river. So they were saying that they like the idea of walking across rather than driving all the way around. So this was an earlier proposal. And this is the one that has been built. It's the position of the bridge was in the end selected by then Chief Minister Pehin Sri Taib Mahmood. Like he thought that the bridge should be in quite a prominent location. So this location was chosen by him basically, and the design was related to what we had at the 2003 design, but also quite different. I should say. So that's a bit of the history behind the project. Then the form, how was the form for the bridge conceived? Actually, you know, the first proposal that came along, the very early one was a C-shaped bridge. Then when it was found it was going to be a bit longer, it became an S-shaped bridge. And then there's different ways of doing an S-shaped bridge. So the conversation that I had with Chun Chien is there.
Yeah, just got in.
Chun Chien, I've been talking too much. I just went through the history of the bridge a little bit. Do you want to speak about how the form was conceived?
Sure. So where are we now? We are at the second stage.
It's the concept design. Like I've just gone through the history of the urban master plan, the Dewan Undangan bridge, and then the Darul Hana bridge, and how the form was conceived.
Right. So the final position of the bridge that we're talking about here was introduced after a competition whereby a viewing platform is introduced. If you notice here, there's no platform in this sketch yet. And the final one, there's a oval-shaped platform. And that is when we changed the monopole support for the bridge to a reverse V. We have two anchor points down there into the river so that it is supporting that platform. So that's how this final form has been turned into what it is today.
So from just one thing that I wanted to mention is if you know what people often feel is that architects and engineers they're on opposite sides of the discussion. Actually, right from the start, the discussions I've had with Chun Chien, we were actually encouraging each other to be quite daring, you can say. So I can remember there was a discussion that I had with Chun Chien, and he said to me, what do I suggest to make this design more interesting? So I said, look, there's two options for how we lean the supports, the two piers which we hang the bridge from. I said, one, we can lean it inside the curve or outside the curve. like the inside the curve would be just, if I can, on this side here. I said, if it's inside the curve, it's very stable. For engineers, it's good. I said, if it's outside the curve, it's very dramatic. And it's maybe more exciting. So Chun Chien's immediate response was, let's be dramatic. And that's actually what decided the form of this bridge. It's we thought, let's go for quite a dramatic design and then make sure that it's still stable and it still works okay. And then, if I remember right, there was a discussion that we said, oh, if we slope it outwards, it looks like the wings of a bird.
Mm-hmm.
And then Chun Chien did this sketch at the top here, which you can see.
Yes. Okay.
My memory is right, Chun Chien. I'm trying to remember. This was many years ago.
Yes. So because of that dramatic angle, it gives a better support to the bridge, and also we introduced a hornbill sort of head to this end of the bridge. With the cable, it becomes the wing that is a soaring hornbill that carries the bridge, the double C.
One thing which I mentioned to Chun Chien when we were discussing yesterday is actually there's no other bridge like this in the world. This one with the support on the outside of the curve. If you look at the bottom right of the screen here, there was a bridge with a similar arrangement proposed in San Francisco about maybe 15, 20 years ago. It was never built. Yeah. So the only one that I know that has been built is actually the one that we have in Kuching. It's a very dramatic design, very daring design, designed by a Kuching team. I'll go on to the next slide. Okay. So this is the form that was initially designed. This was before we added the viewing platforms. But you can see already the triangular truss that the walkway is on. That this triangular truss here, that's a cross section and a longitudinal section. It's already the form is starting to take shape. This was maybe 2003, 2004. And then the whole idea of symbolism. I think Chun Chien, you better explain about this one.
All right. Okay. The symbol of this bridge, we call it Yin Yang, mainly is the connection between the city north and the city south, which in a way we sort of making the bridge as a symbol of harmony for the people of Kuching City North and City South. So symbolically, it is a link between a historic part of the city, the City South, and also the what they call administrative center of the City North, which has the purpose of unifying or harmonize the residents in the Kuching city in a way that bridge also link the northern part civic area, which is the Dun building and the Wisma Bapak Malaysia and the park surrounding that area towards the city south, linking the mosque, the courthouse, the Sarawak Museum, and the Reservoir Park. So these are all the whole series of civic space that is linked by this so-called Harmony Bridge.
The other thing was that the hornbill, which it's the symbol of good fortune. So my understanding is in Sarawak, if you see a hornbill flying in the sky in front of you, you think, oh, it's my lucky day. So we put two hornbills. We put two hornbills in the middle of Kuching. So we hope this brings good fortune and prosperity to Sarawak. And so that's part of the symbolism. And the next one here was about Chun Chien. Do you want to speak on this one or how?
You go ahead.
Okay. No, it's, when we were introducing this design, actually, the design is very much about finding balance and harmony. because you've got two towers which pull the bridge in opposite directions. So the only way to get this bridge to work is you have to balance all the forces. And only by balancing the forces which result from the towers which lean in opposite direction, you can find a structure which is in harmony and which will stand up. If it's not balanced, it just won't work. So actually, we spent quite a few weeks or months, I should say, trying to find the perfect shape for this bridge. The curvature had to be exactly a certain curve. The angle of the tower, which is about 45 degrees, it had to be exactly at a certain angle for all of the forces to balance off and to be able to get the cables in the correct place. And as we were doing all of this, we said, it's the same process that the leaders of society have to go through to find balance within society. You've got different, different races, different faiths, all sorts of different groups of people in society. You have to find balance between all of these the ethnic groups, the religions, etc. And once you find the balance, you find that you have a harmonious society. So it's, where wise leaders have brought balance and harmony to people of diverse races and cultures and enabled them to pull together to form a dynamic and prosperous society. This was in the initial proposal which we sent to the state government, if I remember right. And so that's the, and I think, it's a bit of a reflection of the growth of Sarawak. 100 years ago, it was known as the land of the headhunters. Then it became land of the hornbills. Now, if you ask me, much more the emphasis is the land of harmony and unity. And this is a result of wise leadership, which has, it's only through wise leadership that this is possible. So, and this bridge is a reflection of this. That's what we were thinking. And so then I thought we'd just go on to some technical background. It's about 335 meters long. The height of the tower is about 50 meters. The width of the walkway is about 3.25 meters. And then there's the client who was the developer for this was the government of Sarawak through the implementing agency SEDC, Sarawak Economic Development Corporation. Turnkey contractor was PPS Naim. Principal designer, Chun Chien, you can see him over there, and me. Civil and structural engineers and mechanical electrical engineers were KTA Sarawak. And it's a local engineering firm. Quantity surveyors, PUBM. Lighting consultant, Phillips, and the main bridge subcontractor was Sidiabina. So very much it's a local team. It's not that this was a design that came in from Switzerland and it was built by some Germans or something like that. This was designed by Kuching boys and constructed by Sarawak boys, I should say. So, and where do the skills for this, the skills which are required to design a project like this? Chun Chien and I were both involved in the Dewan Undangan project, which is right next to the bridge, basically. And the familiarity with curved structural forms. I think, Chun Chien and I were both on the Dewan Undangan. I was working in New Delhi on the Lotus temple there, the Bahá'í Lotus temple. And that's, until now, it's one of the most remarkable structures, which the geometry is very, very complicated. It's more complicated than Dun and even our bridge, I should say. But if one's very systematic and thinks it through, everything is possible. So this was the familiarity with curved structural forms. Then with the actual bridge shape, we were actually asked by SEDC to design a footbridge in Santubong Jungle Trek. It's actually near Damai Resort. And so this is the bridge that we designed there. It's a 75-meter long cable-stayed bridge. And it's very much a quarter-scale model of the Darul Hana bridge. The width of the walkway is about a quarter. The span is about a quarter. In many ways, it's just a small scale model of the Darul Hana bridge. And maybe it was this bridge and the glass staircase. If you look on the top left of the screen, you'll see there's a picture of the Sarawak State Library glass staircase, which it's also a triangular steel tube truss is the structure of the staircase, which is the same as the Darul Hana bridge. And so basically the ideas from the staircase and this walkway at the Santubong Jungle Trek, we took the ideas from this and we introduced it into a more prominent location, I should say. And so that's a bit of the technical background. This is a comparison with some other bridges, which are similar idea, I should say. The Langkawi one, I think Chun Chien, you were familiar with the Langkawi one before.
Yeah,
no?
yeah, right.
And it's in West Malaysia. The other three, the two on the left, the top one is in Germany. The one at the bottom is Sorry again. Yeah, the two on the left are in Europe. The one at the top right is Langkawi. At the bottom right is in the States. So it's not as if this is the first S-shaped or C-shaped bridge which has been built in the world, but it's the first one where the tower is on the outside of the curve, sloping outwards. If you see the one at the bottom right, it's on the outside of the curve, but it's sloping inwards, which, if you ask me, is the wrong direction. But we won't argue with the Americans, I think. Yeah, I'll go on to the one at the top left, the Saznitz one. Actually, the engineers for that one, they assisted us with they were a sub-consultant to the bridge subcontractor Sidiabina. They approached SBP to assist with the construction engineering on the Darul Hana bridge. And so then we come to the geometry. The geometry basically is we went for circular curves, and in plan and in elevation it's circular curves, and we went for, if I remember right, Chun Chien, the slope was 1 in 12, I think. The maximum slope for the bridge, and that was for disabled access. Yeah, and if one wants to allow wheelchair access to the bridge, one can't have it very, very steep. So 1 in 12 is just about okay, I think. The other thing that it enabled us to do is one had to have 12-meter clearance in the middle of the river to allow ships and boats to go underneath it. So because the length of the walking length was a bit longer, and so we had a little bit extra length and the 1 in 12 slope. By the time we got to the middle of the river, we had this required clearance for the ships to go under. So that was the geometry of this was part of the design development, that once you have the concept and the client has expressed an interest in the design concept, then you have to go into details. And the next step was to freeze the geometry. So this was freezing the geometry. Then on the engineering side, on my side, we had to decide what were the design standards that we would design to. So mainly we decided to go with British standards and bridge loads from the UK. And there was some European codes for bridge vibrations and things, and for Earth. And so this was the design standards that we, on the technical side, we decided to go for, and the loads that we designed the bridge for. I think mainly it was British loads. For vessel impact, it was American. For earthquake, it was Indonesian. So we just chose what we felt was the most appropriate for designing in Kuching. And I think most of these have been used for other bridges, like our associates, KTA, They have a lot of experience designing bridges in Sarawak, whether it's pedestrian bridges or vehicle bridges, etc. I think many of the very large bridges in Sarawak, KTA have been very involved in them. So for them, this the design process was very, very familiar. So that's the loads. Then the next stage on the technical side is to get a survey of the riverbed done. And so this is the survey that was done to find out how deep is the river there. And we could find out where we wanted to place the piers, whether it was going to be safe. So we did a survey of the depth of the river. This is the survey that was done, the topographical survey. And after that, one tends to go for geotechnical investigation, because we have to support the bridge hangs from towers. The towers are supported on these piers which go down into the ground. So we have to know what is at the bottom of the water of the river. There's sand and clay. Below the sand and clay, there's rock. So this is the geotechnical investigation, which identified very clearly that you have some very weak clay underneath the river, which we could not use for foundations, but underneath that we have some good rock. And that's what the bridge is founded on. And then the piles were supported on the pile cap here. You can see that there are some raking piles at the bottom, and they're supported on quite a deep pile cap. It's about 1.5 meters deep. And that's what you can see in the red oval shapes here. It's right at the water level. And it has to be designed for vessel impact, etc. And then we went for the towers. Chun Chien, actually, your design for the towers was better than the one that I suggested. Maybe you should explain a little bit.
Okay. As I mentioned earlier, the platform came into the picture only after the competition. So in order to support the platform, we introduced a V-shaped tower where there are two support at the bottom of the pier, supporting on two sides of the oval-shaped platform. So with that, the pier become more stable, you can say, and also it gives the tower a more stable shape to support the whole suspension bridge.
Yeah, this change that was made by Chun Chien, I mentioned to him yesterday. He introduced this change for architectural reasons, but actually from an engineering point of view, he did me a great favor, I should say, because after he introduced that egg-shaped platform, the oval platform on the other side of the tower, on the opposite side from the tower, from the walkway, it made the whole design much more balanced. And the first design we just had a single tower. Now it's a V-shaped tower, the upside down V. This new V-shaped tower was much more stable. So I should say thank you very much, Chun Chien. Much obliged.
Welcome.
And so it's this is what happens, as I mentioned earlier, when you have harmony between the different disciplines in the project, and we try to work together. Actually, we find that we can make little changes that it suits you, but it actually helps the other discipline also. This is a perfect example for me. So this was the design of the towers. Then the walkway itself was about 3.25 meters wide. And you can see this, it's S-shaped here. And I guess you could say that S stands for Sarawak also. And so that it's basically a triangular truss. You can see the cross section here. The perspective. This was taken from our computer analysis. And what we found is that if I remember right, the top part of the truss was going into compression, and the bottom member, which is in blue here, it goes into tension. And it's because of the curvature of the bridge that you get different forces in the top of the truss, and it's quite an unusual. The whole design of the bridge is very unusual, but fortunately very stable also. So it worked very much in our favor. So this was the walkway of the bridge, And then again, this was the viewing platform. Chun Chien, you better say something because you're the one who introduced this one.
In the competition, actually, the brief calls for a viewing platform, a tea house, a possible commercial area along the bridge. So it was supposed to be a capsule, a glass capsule, where you could aircon the whole thing, and you could have a tea house in there. So because of the budget and so on, we will reduce it up to just a viewing platform at the moment. Maybe in future we could introduce something more there for the public and for the tourists. Yeah.
But it works very well, I think. Like often when you're walking over the bridge, I found there's many people on this platform here just enjoying the view because you get a nice breeze there, and it's one of the nicest views in Kuching, I think, really.
Yeah, yeah.
But actually the position of the viewing platform, the one on the left here, it faces Dun, so you get a wonderful view of Dun here, and the one on the right here, actually you get a wonderful view of the Astana. So just the position of the two viewing platforms, you get beautiful views of Dun and the Astana, and good place for taking pictures for Instagram and all that sort of thing.
Yeah, actually, when you're talking about the view, this bridge, the geometry of it has the advantage of giving you, or the people are walking along the bridge, a different perspective or different viewpoint of Kuching. When you walk across from this side, you could see the Astana and the Dun building. When you walk across from the other side, you could see the whole Kuching city south, the waterfront, giving you a better image of the whole city, you know, from that point.
It's a beautiful view, like from the middle of the bridge, from the viewing platforms. It's like for me, I was surprised when I walked over it first time. I thought, oh, very beautiful city we have here, but which we knew before, but it sort of reinforces it.
Yeah.
So then this is about, you know, I mentioned earlier that we had to balance the loads. So before we did the computer analysis, we worked out what is the load from the blue elements here. You can see the viewing platform is all the loads. This is the center of gravity of the viewing platform. Then you have the orange tower just at the back here, which supports the viewing platform. This is where that load is coming down. The walkway, if we calculate this red walkway, actually it's constantly changing. But we can calculate the center of gravity of a curved walkway. And the center of gravity of the curved walkway was here on this red line here. And then the green tower, which everything is hanging from, the weight is way over here. So once we added all of this up, we found actually it's quite a balanced design. And what really helped us, as I should say, is Chun Chien's platform on the left here. It made everything balanced, you know. Until then, we were struggling a little bit, but after he introduced his platform, thank you very much, Chun Chien.
That's
yeah,
a counterweight, yeah.
It's a counterweight. It's absolutely a counterweight, and I was so grateful that Chun Chien introduced this one, I should say. So this is the idea of finding balance between, you know, between structural forces and between professional disciplines, I should say. So after we found the balance by hand analysis, you can say, that's, you know, that analysis was going back to first principles. Then we put it into the computer. And this was the computer model. We use a program called SEP 2000. It's a very powerful program from the States. Like for bridges like this, it's probably the best software that you can get. And our office, it's a Kuching office. We're very, very familiar with this. And our associate engineers, KTA, they've been using it for many years also. So it's the analysis of this bridge to a certain extent was maybe the easy part. We put lots of different load cases inside, and we found out what's the worst case loads, etc. And everything worked. And so then we had the confidence to freeze the design. And as part of it, we had to decide what were the cables that we wanted to use. So there's for a cable stayed bridge like this, there's different companies which produce the cables. There's VSL, there's basically from France, Switzerland, and Germany. So we decided to go for the Pfeiffer-Galfan cables. One reason is that they're very simple and easy to install. The other thing is actually very cost effective. They're the cheapest option, which of course is very attractive to everybody. But we looked at everything. We looked at VSL, BBR, PSC, Freycinet, and all very, very good cables, maybe a little more expensive, no great advantages maybe. And so then in the initial design, Chun Chien, I don't know if you want to mention about there was an idea to have a glass walkway, no?
Yeah. That's why it was called the Golden Bridge in the very beginning, with the light penetrating through the glass surface, the golden color light. So it's like a golden belt that span across the river with ethnic pattern on top. But in the end, we did not go ahead with it because of practical reason also. And considering there could be people with height phobia who have problem getting through it. So in the end, we changed it to a solid platform.
The idea was that it would be lit from below, so it would glow like a lantern as you walked over it. It would be sort of translucent glass, not transparent glass. But there's many glass bridges in China, and they've had many problems with them. So I think it was a wise choice to be a bit prudent and not take risks on this one, which is a link between the two sides of the river. It's not a tourist attraction on a mountain somewhere. It's in the middle of the city. So this was the initial proposal for this one. So then we built up a 3D model in some software called Rhino, which as architects, you're probably quite familiar with it. This is the 3D model that we have. It's got all of the elements basically. And we printed out we've got some 3D printers, these MakerBot replicators. We printed out a 3D model. Like we had to build it in stages because the printer can't print the whole thing in one go. So we print one section and then we'd glue everything together. So this is the 3D model that was built to make sure that we understood everything and the topography, and also to show it to the client and the contractors so that they understood what the project was really. Otherwise, very difficult to understand. And so then this was the project launch was in 2013, already 8 years ago. How time flies. And Chun Chien, this was to the State Planning Authority, you said. That's the usual procedure, is it? Yes.
We submitted this one to the State Planning Authority.
Yeah, so this went to State Planning Authority. And then this was,
after the competition was done and announced that this bridge would be the winner, that's what we did. Then we do the launching. Go ahead, Kamal.
So this was the project launch in, if I remember right, August of 2013. And as you can see, Chun Chien is very proud standing there. And this was the whole team. This was SEDC. This was the KTA team. This was the PUBM team. And it was a privilege to share the platform there with these guys and take this picture. And so this was the start of the after this, things got very serious because we knew we had to build it. And this was the launching by the Right Honorable Pehin Sri Haji Abdul Taib Mahmud, the Chief Minister of Sarawak. And I remember everyone in Sarawak was at this launch. It was quite a grand occasion at the Dun building, at the Dun building.
Right.
Yeah. And then we had to go into buildability. We had to find a way to, we're running out of time, so I'm going to talk a bit fast. This is the construction sequence. We had to discuss with the contractors different ways. So these are 4 stages, and then 5, 6, 7 here. You know how to build something like this. And again, the main bridge subcontractor Sidiabina, they engaged the German engineers. Schleich Bergerman, who also gave a hand in the construction sequence of the bridge. And then construction starts. You can see here you have they put in the board piles. At the top left, at the top right, the formwork for the pile cap. Then you can see they've cast the pile cap already at the bottom left, and they put in the bars for the main support piers. And then at the bottom right, you can see the concreting for the main support piers has gone on, and the steelwork is starting to be erected. So this was happening in about 2014, 2015. And by 2017, things got very serious. This is when the tower was pretty much up. I think this one picture on the right is when the last section of the tower with the hornbill was lifted up. You can see in the picture on the left, the steel cables are starting to go in. It means they're starting to lift the walkway up also. And this was the stressing of the first of the steel cables. Also sometime in 2017, it was very nice to see the cables going in, because this was the start of the complicated part of the construction. This was May of 2017, if I remember right. At the beginning of May, you can see the central section of the bridge is missing. This part here, it hasn't been lifted up yet. And within a few weeks, I think 2 or 3 weeks, everything was done. This is, you can see it's almost linked up in the middle here. There's just one little gap there in the middle. And one day at the end of May 2017, we lifted up the final bridge segment here. You can see it being dropped in place. And at the top here, I don't know if you can see that at the top of the slide, you can see that's me shaking hand with the engineer from PPS, Ajeng, who was there also just to celebrate the closing of the bridge, you can say. Once the bridge was closed at the middle span, the whole structure becomes stable. Until then, it's all a little unstable. So we were all very happy. And again, as I said earlier, this is a Sarawak project. All of the boys in this picture are from Sarawak. Yeah, there's me. There's one Orang Ulu and two Ibans in this picture. So it's local produce. And then this was the celebration in November of 2017. Biggest firework display I've seen in my life. It was a very wonderful occasion. And the month after the opening ceremony, there was the regatta where the Sultan of Brunei was invited down, and all the VIPs had their boats there. And you can see the crowds on the bridge. The name for the slide I wrote at the bottom was load test, because you can see there are hundreds of people standing on the bridge. It was a good load test for the bridge. So, and this picture also, you can see we designed it for 5 people standing on every meter squared of the bridge. I think not far off that in this picture. It's absolute shoulder to shoulder crowds there. Everything went fine. Mm-hmm. One thing which didn't go so fine was the vibration. There was a little bit of sway at the beginning, if you remember. And as I say to people, one can calculate things, but the proof is in the pudding. And sometimes the movement is a bit more than expected. So at the beginning, because the movement was a bit more than expected, these tuned mass dampers were installed. Like this picture on the bottom right, this is a tuned mass damper. There's just a few of these underneath the walkway. No one ever notices them. As soon as there's a bit of a sway or a wobble in the bridge, these tuned mass dampers, they can remove the wobble. And that seems to have been very, very effective. And so then, as I said earlier, this is it's a project about balance and harmony. This is the design team. You can see Sarawak boys from all and girls from all races, ethnic groups, etc., all working together happily. This is the design team in harmony. Then we have construction team in harmony, same situation, multi-ethnic, multicultural group, local boys, all building a very outstanding project, I should say. And then we have consultants and contractors working together in harmony. And very pleased to say, architects and engineers, Chun Chien, been a pleasure working with you. It was a great honor, I should say. And one thing I would like to say is, that I mentioned is only through a conscious effort to find balance and harmony can we develop the team spirit within any project and to produce the best results in quality, cost, and speed. It's a result of working together, finding balance within the team, working harmoniously. We can end up with a beautiful project such as this one. That's all I have to say. Chun Chien, I don't know if you want to add something there.
Oh, thank you for this opportunity, guys.
I think this is the end result. This is what was produced at the end of the day, and we open for questions now. I think, and we've gone a little over. I'm sorry, but not too far, I hope.
No problem. No problem. Thank you very much for the fascinating talk. I believe our curious audience may have some questions to ask Mr. Kamal or Architect Chun.
Maybe I pause the question first.
Okay, sure. Go ahead.
For the V-shaped concrete, it's such a huge and massive thing. How do you mobilize the thing? Is it cast on site, or do you mobilize from somewhere to that location? How do you do that? Yeah.
These V towers.
Yeah,
if we go back a few slides here, you can see them being lifted up. Here, you can see the tower, the very tall tower is actually steel. It's a hollow steel. It's a hollow steel box. So you can see here, all of the tower from here downwards is in place. This one from here until the top, this is being lifted up as by this crane. Yeah. So the tower was lifted up in stages, and I'm not sure if you can see here also. The two towers actually, until the level of the walkway, are concrete. So what's underneath the egg platform, that oval platform in the walkway, is concrete. What's above the walkway level is steel, because it should be a bit lighter and a bit stronger, and it makes it much easier to balance, actually. And so, we basically choose the materials and the construction methodology. It has to be buildable, it has to be easy to construct, and it has to be balanced. That it has to stand up in the end. So, that's the process that happened here. So if we go back here, you can see that, where is that picture? This one here. See, everything underneath here, it's a concrete tower. This bit that sticks up here, the V, upside down V, it's actually steel. It's a hollow steel box. Okay.
Another one from me. For the piling inside the river, maybe you can tell us, how do you do the kind of piling? How do you mobilize the crane to do such pile under the river? Yeah.
Basically, you find a contractor who knows how to do the job easily. Actually, there are many very good contractors in Sarawak who are experts in bridge construction now, because there are many big rivers. There are many big rivers in Sarawak. So you've got bridges over the Rejang River, the Baram River, maybe soon the Batang Lupa. There's a lot of very big bridges and big, because there are many rivers. So I think the contractor who did the piling here, he already had all of the equipment. So basically, you drive a steel tube, a big steel tube, and we probably have a picture of it here. Yeah. You drive big steel tubes into the soil at the bottom, and then through this, at the top of this steel tube, you can fix the machine for boring the pile. And then it bores down through the middle of this tube, down through the soil into the rock below. And but you have to have somebody who has the experience. Fortunately, Sarawak has these people. There are some very good contractors there. They have all of the equipment.
Yeah, okay. I think that explained. Just some question from the
we have two questions at the chat box here. One is from Survey Gui. Can you share a bit about the aspect of costing targeted versus actual? And the second question from Chula, how would you know the load test will not fail?
The first one, yeah. If you ask me, the first one, my understanding, this is between the turnkey contractor and the government. My understanding is this was on budget, yeah, and the budget, if I remember right, Chun Chien, you maybe remember better, was 35 million ringgit or so. And if you ask me, it was within that, yeah.
Right.
So we always complain and we say, oh, projects go over budget, over time and everything. My understanding is both Dun, the Dewan Undangan project that me and Chun Chien were involved in, and this project, but more or less on time, on budget. So we are very, I should say, proud to be associated. And so that was the, and we designed to cost, yeah? Like I remember there was one time where one of the managers from PPS, he said, look, they're costing it up, it's over budget. So I said, how much do you need it reduced by? Engineers can always find a way to use a little bit less concrete, a little bit less steel. So we found a way to design it a bit more economically. And but then the construction has to be done in the same way. You know, one has to decide at the beginning of the job, you are going to meet the budget. And as far as I know, that's what happened. The other question was, how did we know that it was not going to fail the load test? This is engineering analysis. We did many, you know, we did many different computer models of this thing. We did many hand calculations. We designed for much worse loading conditions than will ever happen. And we were, you know, everything that we calculated, it showed that this was a stable design. So even the loading that you saw with hundreds and thousands of people on this bridge, actually our analysis for this bridge, it was much worse. You know, we calculated based on much worse loading conditions, and it was always stable. So then we were confident.
I remember we also allowed the loading for a car to drive through, right?
Yeah, what we designed for, you could drive trucks over this. It's much worse than car loading. Yeah, so if anyone can get their car onto this bridge, you can drive across with confidence.
Okay, that's interesting. Anything else from the audience? From an architecture point of view, I would like to ask Architect Ng, at least I think the bridge has served a purpose of, you know, complementing the scale of the dune building there. Is that intentionally achieved, or it just so happened to be like a complementary element to the dune building there?
Yes. In fact, after the completion of the dune, we were already halfway going through this competition, and the intention of the then Chief Minister Bahá'í to move the bridge across this position is also to allow a better viewing point for the dune building, and at the same time it's a good gesture to sort of connect the civic space from the city north to the south. So in a way, this is more like a celebration for the dune building, and also to connect this so-called civic space. With that, I think the city north and the city south has a very good connection, you can say, for the public and for the tourists. It gives people coming elsewhere a better idea, a better perspective of how Kuching looks like. Yeah.
Yeah. Go ahead.
For me, yeah. It's also very much a statement of confidence. You know, this is a very daring design. You know, it's a daring design, and you know, it's for me, it's a reflection of our confidence as architect and engineer. We are confident. You know, this is our design. It's designed by Kuching boys. We proved it works. But it's also a gesture of confidence by the state leadership. You know, for the leaders of this state to have the confidence to go ahead with this project. If you ask me, this is truly daring. And it's a great honor for me and Chun Chien, if you ask me, that they had confidence in us, that they trusted us that we could deliver this. And so, you know, for me, it's a professional, but it's also a reflection of confidence of the state and the people of Sarawak.
Yeah, right.
Right, thank you. There's another question. May I know why the design at both ends of the bridge is different? On the night, it has a swirl up upon going up the bridge. On the right, it has a swirl upon going up the bridge. What would be the reason behind this? Yeah.
If I remember right, Chun Chien, the ground
Yes.
at both sides of the river is at different levels.
That's right.
On the north side, it hits a hill. There's a little bit of a hill there. No?
Yes, that's right. So in order to come down to the waterfront level, we have to go further down. So in order to allow that kind of gradient for the ramp to come further down, we have to sort of twist the end of the S a bit to allow that ramp to happen. And it has to clear the headroom, and it has to look good in the overall shape. So that's why it is the last twist is introduced in the end.
It's practical reasons. One has to meet the side of the river on both sides. On one side, it had to go down to the waterfront level. On the other side, it hit this hill, which is maybe 10 meters higher.
Yeah.
So that's why both sides of the river are slightly different. So it's basically for practical reasons.
Yeah.
I think related to the question, there is another one question asking any alternatives besides being a viewing platform. I believe this is referring to the eggshell structure you have there. The viewing platforms.
The initial idea was to have a coffee shop there, Chun Chien, no?
Yeah, that platform is supposed to be a tea house, a commercial area where the tourists could, stop halfway, have a cup of tea, and enjoy the view. It's supposed to be a capsule shape, like a bullet shape glass platform with all the amenities inside. But I think that would be, depending on the budget in future, we could introduce that, so that initial viewing platform was part of this idea of a capsule or tea house.
It may happen in the future, I guess. When there's some additional budget or something, maybe we will see some tea house there.
That's right. We can we always welcome Starbucks or whatever tea house on top there. Then people could enjoy coffee.
Let's just hope so, eh?
Yeah.
All right. Is there any more question? I think if there's no other question, I would like to wrap this session. I think anyone? Okay. My takeaway from this lecture to just now, I think the project is pretty much local, as you said. It is designed by Kuching people, Kuching boys. So apart from being a bridge itself, it serves as a statement that our local talents can produce a remarkable structure. It shows our confidence in our own technical know-how. And the word harmony itself is not just a name, but it encompasses the whole theme of the process. Now, this is also interesting to me because at least we were made to believe that engineers and architects couldn't work together. But in this project,
see, Chun Chien is my brother. Chun Chien is my brother.
Yeah.
Believe me, he saved my neck several times.
So the healthy camaraderie is apparent. Yeah? Even in this lecture today, we can see that. So we hope this can be maintained for not just this project but for other projects as well. Is there any closing statement from both of you before we wrap this session up?
It's been a pleasure. Actually, since the project, me and Chun Chien have never discussed it. This is the first time that we had the opportunity to think it through and to remember a lot of these wonderful memories, I should say. So thank you very much for providing us this opportunity. Greatly appreciated.
Thank you very much, Mr. Kamal. How about you, Mr. Architect Ng?
Yes. Yeah, this is only opportunity I get to talk about this publicly. And I want to thank UNIMAS for giving this opportunity. And I think this bridge has become an iconic symbol for the city of Cochin, almost like the Eiffel Tower to Paris. So people remember this bridge when they talk about Cochin. So I think a city needs an iconic building and an iconic symbol for the people to appreciate and to remember it by. I hope you guys could proceed. I mean, the government could proceed with the second phase to introduce a tea house and whatnot to the bridge, and
Also
giving
good
the
idea.
public better place to have tea or coffee. Okay.
Yeah, thank you very much. Is there
Thank you
anything
very
from
much.
Mr. Mervin? Mr. Mervin, perhaps would you like to?
Nothing, but
share
thank you
anything?
for both
Alright.
Mr. Kamal and Architect Ng. This session will be recorded and uploaded in YouTube. So later on, you can share it to anyone you want. Yeah. Okay.
All right. Thank you.
Thank
All right.
you.
Thank you very
so much,
much,
everyone. Thank you, everyone. Thank you
Much
for
appreciated.
being here.